This is the Unit 4 test review. As we go through this, make sure you have your review in front of you and you're writing down each thing as we go through it. Use the pause button to pause if we're going too fast so that you can have all of the material. Also, you need to prepare questions throughout this video. Just write them on the side of your paper to make sure you have any questions or misconceptions answered prior to the test. So on the first one, it says, solve the following problem. Be sure to justify each step as you do it. So this first problem can be done one of two different ways. So we're going to do one way, then I'm going to erase it, and then do the other. So you guys can choose which method you prefer. So on the first method, you would distribute this -3 using the distributive property. And your result would be -3x plus 9 equals -27. So from there, we have to get rid of the constant first. So we subtract 9 from both sides using the subtraction property of equality. Which would result in -3x equals -36. And then you use the division property of equality to isolate x, and you get x equals 12. So the other method that you could do to solve this, so if you prefer distribution over division, go ahead and write this method down. And I'm going to erase and start over to show the other method. So the other way that you could do this is when you distribute, you're multiplying all terms on one side of an equation by that number that's outside the parentheses. So the first step you could do is to divide both sides by this -3. That takes care of the -3 on the outside and leaves you with x minus 3 equals -27 divided by -3 is positive 9. So that would be your division property of equality. From there, we have x minus 3. So to isolate the x, you have to add 3 to both sides using the addition property of equality. And you're left with x equals 9 plus 3 is 12. So there's two different methods you could use for solving that one. Use whichever one you prefer. So now we're going down to these inequalities. It says, solve the following inequalities. Be sure to graph them on a number line. So we have the first one. This is a two-step equation. The first thing you get rid of is the constant. So we're going to add 22 to both sides of the equation, the inequality, and we're left with -3x is less than or equal to 42. So from there, we divide by -3. And because we're dividing by a negative, we must flip the inequality sign. So it once was less than or equal to, now it's greater than or equal to. So we're left with just an x on the left side, and 42 divided by -3 is -14. So on your number line, what we know about this is that it should have a closed dot because of the or equal to, and its x is greater than or equal to, so we're going to shade or draw an arrow to the side of the number line that has the numbers greater than -14, which is the right. So I'm going to put -14. I'm going to skip over 4 of them and put -10. This would be -15, 16, 20. There we go. So again, with it being greater than or equal to, it's going to be a closed dot. And because it's greater than, your arrow is going to the right, for all the numbers are larger than -14. For the next one, Again, we can start this one of two ways. You can either distribute or you can divide. I think majority of students in my class distribute, so that's the way I'm going to solve this one. So we have 4 times x is 4x. 4 times 3 is 12. So we have 4x plus 12 is greater than negative 12. So at this point, we move our constant first. So subtract the 12 from both sides, and you're left with 4x is greater than negative 12 minus 12 is negative 24. Last but not least, divide by the coefficient 4, and x is greater than negative 6. Now on this one, we divided by a positive, so we do not have to flip the inequality. We simply leave it as is. So we have negative 6. I put 0 here and negative 10 there. So because it's greater than, I know it's going to be an open dot. The or equal to makes it a closed dot. So this is greater than negative 6, which means negative 6 is not part of your set of solutions. So that's why we use that open dot. And x is greater than, so our arrow needs to go to the right. Your shading needs to go to the right. All right, the next one is slightly different. So we still have that constant off to the side that's not touching your variable. It's not included in the fraction of your variable. So that's still the first thing we get rid of. So we have plus 2 on both sides leaves us with negative 2x divided by 7 is less than or equal to 8. So to get rid of the fraction, you multiply both sides by the denominator, and then we're left with negative 2x is less than or equal to 56. Last but not least, divide by the coefficient negative 2, and x, we divided by a negative, so we flip our inequality to a greater than or equal to negative 28. So down here, we're going to put our negative 28, negative 30, and then over here I'll put negative 25. So because it's a or equal to, it's going to be a closed dot because 28 is in your set of solutions, and x is greater than or equal to, so our arrow is going to go to the right where the x values are larger. Moving on to the next section. So in this, we are solving for x. Be very careful. Make sure you always read what variable you're solving for. So x is on the left side of this equation, so I'm going to try to get everything else to the right side. So when I read this, I have a times x minus by divided by c equals d. So divided by c is the last thing I said on this side, so it's the first thing I'm going to get rid of. So I'm going to multiply both sides of my equation by the variable c. And then we're left with ax minus by equals cd, which you can also write as dc. So we're still trying to isolate x. Here's x, it's touching the a, but it's not touching that minus by, which means that minus by is the first thing we get rid of. So we're going to add by, because it's the opposite of subtraction. We want it on the opposite side, which leaves us with ax, a times x, equals, and write down exactly what you see, cd plus by. Last thing, that a is a coefficient to x, and we get rid of a coefficient by dividing by it, which means we'd be left with x equals cd plus by divided by a. So when you get to your rearranged formula, you should still have every piece of the original formula somewhere in that, unless it was a number that could have been simplified. So the c should still be there. D, b, y, a, and x should all still be part of that equation. So on this one, it says solve for B. So our first step is that we want to isolate B on that side. So we have a positive A, so we're going to subtract A from both sides. And for some people, it helped when they wrote it on the right side, or once they moved it, they put it up next to the given parts of the equation, and that made it a little more visual. So A minus A is 0, and we're left with negative B plus C equals 3D minus A. So the next thing to get rid of is the C. It's plus C, so we're going to subtract C on both sides. This goes away, and we're left with B equals 3D minus A minus C. Negative B, there we go. So now B is not by itself until it's positive. So we want to get rid of the negative 1 in front of the B, the negative 1 coefficient. So we're going to divide everything by negative 1. And when you do that, this becomes a positive B. And then we have a positive and a negative makes a negative 3D. Negative A divided by negative 1 is positive A. Negative C divided by negative 1 is positive C. Last one in this section, we are going to distribute first. So we have 8x minus 28y equals 6x plus 26y. So in this one, it says solve for y. So we're trying to get y by itself. So I'm going to move these 8x's to the left. So it's a positive 8x. So I'm going to subtract 8x and line it up under its like terms. So 6x and negative 8x are like terms. So we want to line them up. So we have negative 28y equals negative 2x plus 26y. Next step, we want to get all the y's on one side, so I'm going to subtract the 26y on both sides, which leaves me with negative 54y equals negative 2x. Last step, we want to divide both sides by the negative 54, our coefficient for y. And that leaves us with y equals 1/27x. So 1 over 27 times x. So our next one says, Cameron is driving on a racetrack. He just completed lap 45. The fastest he will drive is 175 miles per hour. Will he finish the race when he hits lap 300? And it says, what would be the inequality that represents his speed? So we already know that he's beginning this track at 45 laps, or the math for this for this race. So he starts at 45 laps. We know he's going 175 miles per hour per lap. So we want 175 miles per lap. So we don't know how many laps he's done, but we want to know if he will be able to finish when he hits lap 300. So it needs to be less than or equal to 300, because when he gets to lap 300, we need to know if he's going to be finished. And sorry, guys, I read his question wrong. So his speed is going to be represented by x is less than or equal to 175, because that's the fastest he will drive. That's his maximum speed, his miles per hour, the fastest he's going on this track. So then it says, given the following inequality, tell what each part represents. So we kind of just went through this and me reading the question wrong. So the 45 is how many laps he's already done. So number of laps completed. $175 is his maximum speed. X represents the number of laps. And then last but not least, the 300. So the at least, or the less than or equal to 300. And that's his goal. He needs to finish the race at or before 300 laps. So that's his maximum of 300 laps. All right. So then we have Amelia went on a road trip with some friends. She recorded the following information on the way to their destination. The trip took 3 hours. The car they took gets 30 miles per gallon. 5 gallons of gas were used. Her average speed was 50 miles per hour, and the price of gas was $3 per gallon. And it says, how far away was their destination? So we know that the trip took 3 hours. And across those 3 hours, her average speed was 50 miles per hour. So we're going to multiply those 3 hours by the 50 miles per hour, which gives us 150 miles. So the destination was 150 miles away. So then it wants to know, are the following equivalent? Are they the same? So you have to simplify them in order to figure out if they're the same. So what they did was they took all of these 5 different representations and mixed them up into different orders, just like we did with Elvira's Cafe. So on the first one, this 2 needs to be divided into the 2 numerator terms. So 4x divided by 2 is 2x. 6 divided by 2 is 3. And then we still have that other plus 3 to bring down. So when we simplify this, we get 2x plus 6. So are they the same? No. 2x plus 6 is not the same as 2x plus 3. So looking at the next one, when we distribute that 4, we have 8x minus 20. And already we can see the other one is 8x minus 20 divided by 4. So they are not the same. And the last one. So if you distribute first, because that is typically what students do, we get 9x, negative 9x, negative 3 times 1 is negative 3, divided by 3. So this is just like the first one. We have to put the 3 in the denominator for both terms in the numerator. So negative 9x divided by 3 is negative 3x. Negative 3 divided by 3 is negative 1, which is exactly what we have on the right side, so they are the same. Moving on to the next page. You are starting a business where you will pick up leaves in order to save money to purchase yourself a new cell phone. The cell phone is $800. You already have $250 from last fall where you did the same thing. You charged $10.50 an hour. Write and solve an inequality that shows how many hours you need to work to make at least $800 so that you can afford the new phone. So we know you already have 250. So you're beginning with the 250. That's your y-intercept. So then you charge $10.50 per hour. Remember, per, each, every. That's your hint that it's your rate of change. So we're also adding on $10.50 per hour. So there's your X. Because if you work 1 hour, you get $10.50. If you work 2 hours, you get $21. If you work 3 hours, you get $31.50, etc. So that's your rate of change. And last but not least, you want at least $800. So if you want at least $800, that means $800 is your minimum amount. You want $800 or more. So we're going to say greater than or equal to that 800. So now we still have to solve this. So this is a two-step inequality. So we want to get rid of the thing not touching x first, your constant. So our constant in this case is that 250. So we're going to subtract 250 from both sides, and that leaves us with 10.50x is greater than or equal to 550. So x still has a coefficient that we have to get rid of, so we're going to divide by our coefficient of 10.50, which gives us x is greater than or equal to, because we never multiplied or divided by a negative, so we keep our sign, 52.38. Now the question says how many hours you need to work. So we don't know if you're going to get paid for a partial hour. So we have to figure out how many whole number hours do you need in order to hit your minimum of $800. Well, since our x value is larger than 52.38, we have to round it up. So x is greater than or equal to 53. Another way to tell is replace it with your numbers. So if we said 52 is greater than or equal to 52.38, that's not correct. So that lets us know that instead of using the 52, we have to bounce it up to that 53. And that's hours. The next problem. You want to know what you need to make on your next algebra test in order to pass the class with at least a B. The averages you have so far on the first 4 tests are 76, 73, 83, and 91. What would be the average you would have to make on the 5th test to complete this task? So we know 4 of the test scores. The 4 test scores are listed right there. So we have 76, 73, 83, and 91. But it says on the 5th test. So we don't know how much you have to make on the 5th test, so there's your variable that represents your unknown. And then we divide it by 5 because that's 5 scores that we're averaging. And we want it to be at least a B. So at least a B means it's going to be higher than or equal to an 80, because an 80 is the lowest B you can get. So in order to solve this, you have to combine your like terms. I'm also going to get rid of the denominator in the process. So I can do 76 plus 73 plus 83 plus 91, and that gives me a simplified 323 plus x divided by 5 is greater than or equal to 80. So we have to get rid of that fraction, that division. So we're going to multiply by 5, which takes out your denominator only and leaves you with 323 is greater than or equal to 400, plus x is greater than or equal to 400. Last thing, you have to subtract your 323 from both sides, and x is greater than or equal to 77, which means that you would have to get a 77 or higher on that 4th test in order to maintain that average of a B. All right, on the next one. If we're going to write these inequalities as intervals and inequalities, the interval for this first one is it goes from negative infinity, because that arrow tells us it's never going to stop going left, all the way till this end point 9. So we have negative infinity, and then because it stops at 9, 9 is a closed dot, we're going to use a hard bracket. So as an inequality, there's two different ways you could write this. You could put negative infinity is less than x, which is less than or equal to 9. And it's less than because you don't actually, you use negative infinity is less than x because you're never going to reach infinity. So we can't say less than or equal to. But then because it's a closed dot, we have x is less than or equal to 9. So the other way you may see this, and this is more like when you have your solutions to one variable inequalities, is you could just have x is less than or equal to 9, because that includes all of those numbers all the way to negative infinity. So our next one, again, we have the negative infinity to the left, which always gets a parentheses, and then we have an open dot at 1.2. Because it's an open dot, we use a parentheses. So our inequality there can be written one of two ways. You can either say x is less than, not or equal to, because it's an open dot, 1.2, or you can write it as a compound inequality with negative infinity is less than x, which is less than 1.2. And the last one, we have an open dot and a closed dot. So our open dot is at 2, our closed dot is at 6. So open dot is parentheses, closed dot is hard bracket. So when we write it as an inequality, 2 is less than x, open dot, so we just want less than. And then we have a closed dot at 6, so we want to put x is less than or equal to 6. So for the next section, we are putting all of these into slope-intercept form. So we want it in y equals mx plus b. I'm going to write that next to this. Y equals mx plus b. So our goal is to isolate y. So the first thing I'm going to do on this one is distribute the x, the 2, and then I'm left with 6x minus 8y equals 17. So we want to isolate y, which means x is the first thing that has to go. So we're going to subtract this 6x from both sides, which leaves us with negative 8y. And then I want it in mx plus b form. So I'm going to put that negative 6x before that positive 17. And then the last little bit is we have to get rid of the coefficient for y. So we're going to divide by negative 8 on all terms. And we're left with y equals 6 over 8 can be simplified to 3 over 4 because 2 goes into both of those numbers. So we have 3/4 x, and then we're just going to leave it as 17 over 8. So our next one. Again, you want y to be isolated on one side of your equation, so we have to move x first. So we have this minus 12x. So we're going to add 12x to both sides of the equation, which leaves us with 2y equals, you want your slope first, so the positive 12x and the positive 24. Next, get rid of y's coefficient of 2 by dividing every single part of this equation by 2, and we're left with y equals 6x plus 12. The last one, we have x and y on the same side again. It's in standard form, so to move it into slope-intercept form, we have to move x, which leaves us with negative 3y, don't forget your negatives, equals negative x and positive 1. So then divide by y's coefficient of -3, and we're left with y equals negative and a negative makes a positive. Remember, there's the implied 1 in front of x, so it's a positive 1/3 x. Positive and a negative makes a negative, so minus 1/3. All right, so in our next one, the easiest way to do these, to compare these things, is to solve your inequality first. So to solve this inequality, we move our constant of 15. It was a minus 15, so we have to add it to get rid of it. And we're left with -3x is greater than 9. So then our next step is to divide by x's coefficient of -3. And since we're dividing by a negative, we have to flip that inequality. So 9 divided by -3 is -3. So it asks, which is greater, which is larger, x or -2? So if we had this on a number line that x is less than -3, there we go. So we have x is less than -3, so it's an open dot, and since it's less than, we're pointing to the left. So this -2 is to the right of our x value, which means that is the greater value, because to the right on a number line is where the larger numbers lie. So on this one, it says, given x is less than y, which one's greater, x minus y or y minus x? The easiest way to do this is to pick two numbers. So I'm going to say that x is 1 and y is 2, because 1 is less than 2. So if x is 1 and y is 2, now I can evaluate for which one is the greater value. So 1 minus 2 makes -1, and 2 minus 1 makes +1, which means that this represents a greater quantity. On to the last page. It says, are the values given part of the solution set for the following inequality? So the way to do this is you can solve your inequality and then evaluate from there, or you can plug in each of these values for x and find out if it gives you a true statement. So I prefer solving the inequality first because it takes less time than plugging in all 8 of those numbers. So I have this -2x minus 4 is greater than -12. So the first step is to get rid of your constant, which is that 4. Opposite of -4 is +4. So we have -2x is greater than -8. So to finish solving this, we divide by -2. And when you divide by a negative, you must flip your inequality sign, which means x is now less than -8 divided by -2 is 4. So any x value that's a solution must be less than 4. So is 2 less than 4? Yes. Is 3 less than 4? Yes. So these are part of the set of solutions. Is 4 less than 4? No. Is 10 less than 4? No. So these are not part of your set of solutions. So is -2 less than 4? Yes. Is 14 less than 4? No. So this is not, that pair of solutions is not part of your set of solutions. And then the last one, x equals 1, which means 1 is less than 4? Yes. 0 is less than 4? Yes. So these are parts of your set of solutions. So again, solve those inequalities first and then evaluate from there. Okay, so this next one, this is using those proofs, those justifications to tell what's going on with every step. So the very first thing is I have this -5 in the denominator. So 3 times x minus 3 divided by -5. is less than or equal to 3. So I'm going to multiply this entire thing times -5. Now, remember, when you multiply or divide by a negative, you must flip your inequality. So because I multiplied by that negative number, I have to flip that inequality. And that leaves me with a -15 on the right side. So now you can distribute. So we have 3 times x and 3 times -3. So that gives you 3x minus 9 is greater than or equal to -15. And I forgot to do my justification. So the very first thing I did was the multiplication property of equality. Because I did it to both sides, it's a property of equality. The next one I distributed, so that's the distributive property. And that one's not a property of equality because it only happens on one side. So it's just a distributive property. So then we are to this next step. So we have 3 times x minus 9. So we're going to get rid of that -9 coefficient constant by adding it. And then we're left with 3x is greater than or equal to -6. And that was your addition property of equality. Last step is we have to get rid of the coefficient 3. So we divide by 3, which is your division property of equality. And x is greater than or equal to -2. So the next one says solve the following to see where the two lines intersect. So on this, the very first thing you have to do is we want to get one of the variables by itself. So I'm going to solve this top equation for x. And then I'm going to plug it back in to figure out where they intersect. So when we divide by 4, that coefficient 4, we get x equals -4. So we know the x part, the x value of the coordinate where these two lines intersect. So I'm going to go ahead and write it off to the side. So now I have to plug it back into the equation that has a y so that I can figure out the y value. So I'm going to plug it back into this equation, which leaves me with 3x is -4 minus 4y equals 24. So 3 times -4 is -12. The opposite of the -12 is a +12. And then to get rid of the coefficient, you divide. And y equals -9. So that means these two equations, if we plugged in a 4 for x, we would get out a true statement. If we plugged in a 4 for x, -4 for x, and a -9 for y, we would get a true statement in both equations. So it's where they intersect. The last section has us graphing and shading the following linear inequalities. So we're going to solve these for y to put them into slope-intercept form and then graph them after we've made some observations. So the first one, we have to move x, so subtract 4x. We're left with -7y is greater than -4x and a +14. Last step, divide by -7. We're dividing each part of it by -7. And remember, when you divide or multiply by a negative, you must flip the inequality sign. And that leaves us with 4/7x, because a negative divided by a negative is a positive. And then a +14 divided by -7 is -2. So listing what you know about this. We know our b value is -2. That's your y-intercept, your b. The m value is 4 over 7. So beginning at that beginning, that -2, we're going to go up 4 and to the right 7. We also know because its y is less than, is going to be a dotted line. And when it's less than, it's shaded below the line. So now that we have every piece of information we need, we can graph this. So we have a y-intercept of 2. We begin at that -2. And then from our beginning point, we go up 4 and to the right 7. We know we're going to connect those with a dotted line because it says y is less than. And because it's less than, we're going to shade below the line. Next one, we need to get it into slope-intercept form first. So we have to subtract the x from both sides, which leaves us with -8y is less than or equal to a -x and a +24. Next step is we want to divide it by y's coefficient of -8. And at this point, if you want to put the 1 there, that's fine. And then we have y, we divided by a negative, so we flip the inequality sign so it's greater than or equal to -1 divided by -8 is a +1 over 8x, and +24 divided by -8 is -3. So observations. We begin at our y-intercept, which is -3. From there, we move 1/8, so it's up 1 to the right 8. Because its y is greater than or equal to, it's a solid line on your graph. That greater than tells us we're going to shade above. So again, begin at your y-intercept. From that beginning point, we go up 1 to the right 8. We know that we're going to connect these with a solid line. And we're going to shade above it. So remember, the areas that contain the shading are the areas that contain the solutions. Last one. We have this inequality, which is already in slope-intercept form, so we can make our observations and graph it immediately. So, ny equals mx plus b. Our b value is -3. Our m is 4, which can be rewritten as 4 over 1, because 4 divided by 1 is still 4, which means we're going to go up and to the right because it's a positive slope. And from there, we know it says y is greater than. So it's a dotted line, and we shade above because it's greater than. So I'm going to begin at my -3. I'm going to move by going up 4 and to the right 1. I know this is going to be a dotted line. And I know I'm going to shade above it. So I typically start at my y-intercept and notice those are the y values that are greater, so I know which side, which region of the graph to shade. So write down any questions you guys have and be prepared to ask them prior to the test.